Let's find the area of a square. You should recall that since a square has 4 equal sides, the area of a square is equal to the side length of the square times itself. A square with a side length of 5 units will have an area of 5 times 5, or 25 square units. Note that the unit for area is square units. If the side length is not known for a square, then other strategies must be used to find its area. In the tilted square, we do not know the length of its side, but we can count the number of square units inside the square because it is on a grid. It is also seen clearly that there are half squares as well. We can easily put 2 of the halves together to count as one whole. When we finish, we know the area of the square is 8 square units. Not all tilted squares are as easy to piece together. We can still use the grid and what we know about squares, rectangles, and triangles to find the exact area of the tilted square by following these steps. First, the blue square is drawn around the tilted square. The area of the blue square is found using the formula side length times itself, so 4 times 4 is 16. Next, at each corner there is a triangle. Piecing 2 triangles together makes a rectangle. We find the area of the rectangle by multiplying the length times its width, or 1 times 3 is 3. Then we multiply this by 2 since there is another pair of the same triangles, giving us a total of 6 square units. Last, we remove or subtract the area of the triangles from the blue square, which leaves the original black square. So 16, take away 6, leaves us with an area of 10 square units. Reverse, reverse. I'm just seeing if you're still with me. Thinking in reverse, let's find the missing side length of a square from its area. If we know the area of a square is 25 square units, and we want to know its side length, we can ask the question, what times itself is 25? We know the side length must be 5 units long, since 5 times 5 is 25. A square root is the length of the side of a square with a given area. It answers the question, what number times itself is blank? For example, what is the side length of a square that has an area of 25 square units? Or what number times itself is 25? We know from our previous slide that the answer is 5 units. So the square root of 25 is 5. The symbol for square root looks like this. The square root of 25 equals 5. When we try to find the side length of a tilted square, or the length of a diagonal line, it is not as exact, and we must either estimate the length using roots that we know, or leave the answer in radical form, which means with a radical sign. For example, what is the side length of a square that has an area of 8 square units? Or, what number times itself is 8? We know that 2 times 2 is equal to 4, and that 3 times 3 equals 9, but we cannot think of a number times itself that equals exactly 8. Since 8 is between 4 and 9, the square root of 8 must be between the square root of 4 and the square root of 9. The square root of 8 is between 2 and 3, a beginning estimate. On the number line, 8 is much closer to 9 than it is to 4. A better estimate of 8 is the square root of 8 is a little less than 3. We would use estimated values in real-life problems. But mathematically, the square root of 8 is exactly the square root of 8 left in radical form. You might notice that the tilted squares are the squares that do not have exact math facts finding their area.